Greetings to all the professors and viewers. I'm Himanshu Sarunke, a part of Team 16, comprising of myself, Saqib Khan, Himanshi Gupta and Masam Joshna. Today I will be demonstrating our DIY assignment 4, which is to make an electronic stethoscope. The materials required to make an electronic stethoscope are an ordinary stethoscope, Arduino Uno, piezo sensor, breadboard and jumper wires. Now it's time for the circuit explanation. This is an Arduino Uno. This is a data cable. Its function is to provide power and relevant instructions in the form of code written on the Arduino Uno IDE to the Arduino Uno board. The data cable is connected from the USB port on any system to the power socket on the Arduino Uno. Following that, the red jumper wire is connected from the A0 analog input-output pin to the live row on the breadboard. The black wire is connected on the ground terminal on the Arduino board to the neutral row on the breadboard. After that, a connection is made between the positive portion of the piezo sensor, which is the white part, to the live row using a red wire. Another connection is made between the negative portion of the piezo sensor, which is the gold part, to the ground row using a black wire. Finally, the piezo sensor is connected to the lower end of the stethoscope. To begin with, heads up with the code. The code was written in view of installing a LED, but due to some problems it couldn't be done. I will go through the rest of the code. So in the beginning of the code, we define the variable pulse sensor to be 0 and its data type to be integer. Similarly, we define the variables signal and threshold to the integer data type. Following that, we define the serial begin function in setup. The serial begin function sets the baud rate for the serial data communication. Now we assign the signal variable to the analog read function, which detects the input from the piezo sound sensor. Then we use the serial println function to reflect the values stored in the variable signal. The delay function denotes the time period between the code accepting two input values. The delay time, which is 50, here amounts to a delay of 50 milliseconds between two consecutive inputs. So this is the final demonstration, and this here is the code that we will feed the Arduino. So in the beginning, I'll press on compile here. So down here we can see it says done compiling, which means that there are no errors in the code. Now I'll press on upload so that the code is uploaded on our Arduino Uno. Now I click on tools and open the serial plotter, which will show us the graphical representation of the input values. Now I'll slowly place my finger on this piezo sensor right here, and now we will observe the graph. So as you can see in the graph, there is one sharp variation and then it is a little bit regular. The one sharp variation is at the time when I place my finger on the piezo sensor. It is because of a sudden change in pressure in a very low amount of time. It is steep. One feature of the serial plotter is that it can change its scale according to the input values. So after a while, right now, it will directly zoom into the variations. So as we can see, this represents my heartbeat. The piezo sensor is detecting the pressure changes at the tip of my finger, which is giving us this graph here. I've counted this and it comes out to be 65 to 70 beats per minute, which is the normal resting heartbeat. So that's all. Thank you for watching, and this was the DIY assignment 4 of Team 16.